Perfect. Nice. Okay. Okay, we still have 2 minutes. I've just used 2 minutes to do the introduction, and I can leave the rest of the time to our speakers. Okay, so for the um, right now, actually, it's our 10th workshop, and we use Mandarin and English for the introduction. 哎，这个各位参赛者啊，大家晚上好，欢迎大家来这个本次2024的博卡克松的第10场的 workshop 的直播活动啊，我还是这个主持人 Tracy。然后咱们这个 Polkadot Hackathon 呢是由这个 OneBlock 举办的这个波卡生态的开发者创业大赛，然后招募面向全球的一些 Web3的技术爱好者参赛，然后也促使开发者们为这个波卡呀 Substrate 生态创作出更多的这个产品，然后带领团队呢投入到这个波卡的生态开发建设当中来。然后 OneBlock 呢，官方也会在咱们这个黑客松举办的周期前后啊，协助开发者创建团队，提供技术指导、引入投资等扶持啊。然后在这里还是提醒一下各个团队啊，大家要创建好自己的这个 GitHub 仓库啊，然后而且要按照这个参赛规范来提交一个完整的项目信息，这也是这个官方评委审核作品的地方啊。如果大家有任何疑问呢，也可以在参赛群里边啊咨询老师或者工作人员。另外呢，咱们这个新加坡的黑客松啊已经结束了，然后曼谷的这个黑客松呢也是4个赛道啊，然后奖金池和新加坡是一样的，是31.5万美金啊，并且可以和这个 Bounty 奖金叠加。然后我们这个 Bounty 呢也是有一些这个更新啊，然后大家也可以查看这个 d o r Hacks 上这些信息啊，然后也是预祝大家取得一个好成绩。Okay, dear participants, good morning and good evening. Welcome to the 10th workshop live broadcast event of 2024 Polkadot Hackathon. I'm your host, Tracy. And Polkadot Hackathon is an entrepreneurial competition for Polkadot ecosystem developer uh, officially organized by Bumpbox, and it recruits Web3 technology enthusiasts from all around the world to participate, promoting developers and create more innovative products for Polkadot and Substrate ecosystem, and lead the team to invest in Polkadot ecological development and construction is underway. OneBlock will also help developers create teams, provide technical guidance, and introduce investments and other supports before and after hackathon. Here we also remind each participating team that after creating your GitHub repo, you need to submit complete project information following the competition specifications. This is where the official judges review your projects. If you have any questions, you can consult the mentors or staffs in the hackathon participation group. In addition, the total bonus pool of the 4 major tracks of the Bangkok Hackathon is 315,000 US dollars, and it can be stacked with the bounty bonus. So here, I wish all project teams good luck. And also, we have some updates for the bounties. I'll just quickly share. Actually, you can get all the infos through our Dara hacks, and you can see right now we have our bounties. We have Viral Network, SAS Network, Unique Network, Bifrost, Darwinia, Moonbeam, Blockchain for Good, and yeah, you can check the requirements for different bounties. Okay, so I've just let me switch back to my slide. Yeah, so today is our 10th workshops. You can see we have Alex, we have Max and Philip. Yeah, and actually we gathered like people's interest, so we're very honored to invite um, like Substrate computers to participate in this workshop and bring you some rich systematical sharings. And their sharings content covers various fields and tracks that everybody is concerned about. And I believe it can provide valuable experience and inspirations for everyone. And Alex, Max, and Phillips will bring you theme sharing. And during the period, if you have any questions, you can record it, and I can forward them after. So yeah, just let's start. Let's welcome Alex, the System Network Dev Real lead to share with you the harnessing SAS decentralized storage with SAS DOSS APIs. Okay, Alex, please go ahead.
Yes, thank you so much, Tracy, for the introduction. Let me share my screen. So, are you able to see my screen?
Yes.
Okay. So again, hello everyone. Thank you so much for joining us today. I'm Alex, developer relationship lead at SES, and I'm really excited to be the part of Polkadot Hackathon. It's a pleasure to have everyone here. So, in this workshop, I'll start thing off by exploring the basics of SES. Then we'll move on to the high-level overview of our SES network architecture. And after that, I'll quickly go through some of the challenges in the industry and see the solutions that SES offers. And we'll also quickly compare SES with other solutions, so you guys will understand why SES is a great platform to develop on. And lastly, we'll take a deep dive into our DOS, which is Decentralized Object Storage Service, which serves as the gateway to the SES network. And I'll wrap up this session with a demo on DOSS REST API to show you guys how easy it is to start developing on SES. So I hope by the end of this workshop, you all will have a solid understanding of what SES is and how to make the most out of the SES. So with that said, let's jump right in. So in a nutshell, SES is the next generation decentralized distributed data infrastructure, which is designed to revolutionize data management and delivery. So our distributed storage network is built on a public blockchain, and we have our own millisecond high-speed decentralized content delivery network. We call it CD square N. And we also provide AI tools through which you can train AI models without actually exposing your original data itself. So I would like to give one example on what actually motivated us to develop SES. So for example, you can imagine uploading a video on any social media or, for example, YouTube. While it is like mostly very convenient to upload those videos, we often lose control over our data. So they can actually modify or even use the data in ways which we have not thought about, or worst of all, they can actually remove our data completely. It all depends on those third parties. So SES is kind of addressing those issues by providing true ownership of data. And we also, our main motive is to provide data sovereignty and control over our data. So this is essentially giving users power of control of their data back to the users. And this is actually what sets SES apart from other solutions. With our innovative approach, we are able to deliver unparalleled data privacy, sovereignty, and scalability. So with SES, actually, you can retain control over your data, and SES network will actually ensure that that it is handled according to your preferences. So let's start with the network architecture. And we'll start from the bottom. At the bottom, we have the blockchain layer. And in this layer, we have like consensus mechanism. We have some other uh, algorithms like validator selection, random rotational selection mechanism. Then we have a proof of data reduplication and recovery, proof of idle space, um, and proxy re-encryption technology. So all of those things build actually the basis for our storage infrastructure, which is used for validating different aspects of, like, for example, data for and sending encrypted data to um, other party. This allows all those functionalities. And on top, we have the distributed storage resource layer, and this layer utilizes virtualization technology to integrate and pool storage resources in the network. So it is composed of a consensus node and storage node. Consensus nodes are responsible for storing metadata and generating blocks. They verify transactions, and they also generate storage challenges for which storage nodes have to provide some storage proofs back to the network that they're actually storing the data. And storage nodes, on the other hand, provide storage space to the network, and they are responsible for storing users' data. And in turn, they earn incentives. And on top of this, we also have our distributed content delivery layer. This layer utilizes content caching technology to achieve fast delivery of stored data. And it is composed of cache node and retrieval nodes. So it combines the advantages of content delivery network and peer-to-peer technology for efficient file access. This effectively reduces the number of proxy servers required uh, and reduce overall costs of the network. So the cache node actually, as the name suggests, are responsible for caching frequently accessed file, and the retrieval nodes are responsible for retrieving file slices from the storage nodes on the network, and they assemble those file segments and sends it back to the users. So right on top, we can see we have the interface layer, and it provides APIs, SDKs, and other tools for which developers can use and access data storage services provided by SES. And on the right, we can also see like we have uh, XAI protocol suite, and the main component of this is SES AI link. Um, this is essentially like training AI models without actually exposing your data. And these are some of the industrial challenges. Actually, I won't get into much details about this, otherwise the session will become too long. So just a glimpse for SES is able to provide high data assurance thanks to our proof of data reduplication and recovery mechanism. And we also provide millisecond data retrieval, like we saw, like we have our own CDN network, and we're able to utilize the whole network storage resources as efficiently as possible thanks to our smart space management technology. We are able to monitor the whole network's underutilized and overutilized storage resources and utilize it efficiently. We also provide SDKs in Go, JavaScript, Rust, and also RESTful APIs, now which makes it like easily applicable for commercial users. Like all the enterprise level applications can actually integrate with our platform. With that, we also have support for EVM and WebAssembly smart contracts. And these are some of the content delivery network industry challenges. Like we already saw previously, we are able to provide low cost services, CDN services. And these are some other challenges and solutions that SES brings. And for the decentralized AI training challenges, like there are like lack of data privacy, mostly while training the data. It consumes a lot of electricity. It requires a lot of computing resources, and it is mostly monopolized by big giants, which is having like kind of ethical and social impacts, and it's actually not very uh, equal. So SES is able to provide solution which is based on Byzantium robust system with data privacy. So we are able to train AI models in a decentralized network without actually exposing the original data itself. And the key advantages of this is it is privacy preserving. It provides decentralized computing. We can synchronize training with our smart contracts, and we can also provide hardware acceleration, and it is extremely easy to integrate. So this is like a comparison table of SES with some of the other decentralized storage industry storage solutions. So this is to give you guys an understanding of why you should actually choose SES to develop on. So first of all, you can see SES is able to provide object storage service, which only Amazon S3 provides. It is very similar to S3. Like you create buckets. Instead of buckets, we actually create territories on SES, and then you start uploading your files to those territories. You can actually transfer those territories to some other users also. And we also have our own CDN network, where Filecoin Arweave they don't have, and Amazon S3 is a centralized S3 service. And for create, read, update, and delete operations are actually supported fully by SES and Amazon S3, and we provide comprehensive data manipulation capabilities. Filecoin supports only create, read, and delete operations, while Arweave only supports create and read operations. This actually limits their management flexibility. And SES, we also have location-based storage selection mechanism, which also, of course, Amazon S3 also provides because they are a centralized server. And Filecoin and don't have their own native support, uh, and Arweave don't have any support for LBSS. For the proof algorithm, we have uh, proof of data reduplication and recovery with the random challenges like our consensus nodes. They provide generate challenges to storage nodes, and those storage nodes provide proof that they are indeed storing the data. Similarly, like Filecoin also have a proof of replication and proof of space-time with challenges, and Arweave have success proof of random access. S3 doesn't require any proof algorithm, being a centralized service. And these are some other like challenge comparison. We provide like high disaster recovery. We are able to guarantee through our proof of data reduplication and recovery mechanism, where if any segment is lost, we have erasure encoding, and we are able to retrieve those missing segments. And on the other hand, Filecoin uh, is having a median data disaster recovery because the file is essentially stored with a single uh, node until unless somebody else actually downloads those files, being an IPFS running at the background. And Arweave also has high disaster recovery because the whole data itself is actually stored on the chain. And S3 provides like cross-region and multi-dimensional replication, which also incurs additional costs. And in SES, we are able to provide Web 2 performance in Web 3 by providing milliseconds data retrieval thanks to our CDN network. Whereas Filecoin, it takes sometimes hours to like download files. Arweave, it takes few seconds, and of course, S3 is centralized and Web 2, so there's no performance issues there. And if you compare storage costs, SES costs somewhere between like $0.2 to $1 per terabyte per month, which is almost like 10 times cheaper to Amazon S3. Yeah. And in SES, you just rent your storage space. Like you pay only for storage, and retrieval is free. Like you can upload and download unlimited times as many times as you want. Whereas Filecoin, you pay for storage as well as retrieving the file. Same goes for S3. And for the capacity, like recently we had around 45 petabyte of storage with around 6,000, more than 6,000 storage nodes. And yeah, you can see Filecoin have like exabytes of storage with 2,200 storage nodes. So this is on our testnet. So yeah. So I guess this comparison table gives you an understanding like why SES is a good choice to choose to develop on SES. And what is like let's understand what is DOSS. Like I said, DOSS is a decentralized object storage service. It simplifies storage services for developers and offers HTTP API for object-based storage service that is low cost, secure, and highly scalable, making it ideal solution for handling unstructured data. So DOSS actually serves as a gateway to the SES network, which uses blockchain-based distributed storage protocol. It serves as a Web3 platform catering to developers, offering capabilities which is comparable to centralized S3 services. You can say a DOSS is the next generation S3 or Google Cloud for Web3. This is the workflow of DOSS. This actually consists of three basic steps. First is you need to have some SES tokens. This can be achieved either through the community or you can buy some SES tokens. For the testnet, we have faucets. And after that, you have to purchase some space on our network, of course, and then you have to authorize the gateway through which we'll be uploading and downloading files to the SES network. And the last step is, of course, like uploading and downloading files. So when a user uploads a file, the file gets to the DOS's gateway. The gateway is responsible for slicing our files into smaller segments and erasure encoding. And then the blockchain assigns which segment will be stored on which storage nodes. And DOSS then distributes all those segments to different storage nodes. And while downloading the file, again, the file are then fetched from all the storage nodes and reassembled and then send it back to the user. And also you can see the frequently accessed files are cached within the DOSS gateway. So we'll start with the REST API demo, and there are some prerequisites. First of all, we need some SES wallet, like a SES wallet account, and we have some DOSS gateways hosted by SES. Based on your location, you can select which location suits you best, and you can choose those gateways. We also have load balancing implemented on those nodes, and these are their wallet addresses, which will use it to authorize our gateway. So those information are actually available in our documentation also. And if you're also interested in setting up your own DOSS gateway, we have the documentation for that as well. So with that said, let's start with our demo for today, like uploading and downloading files through our DOSS gateway. So the first step is to authorize the gateway. So for that, I've already opened our Explorer, which is testnet.ses.network. And from here, we can navigate to developer and extrinsics. You can select the account which you want to use. I'll just show my account. I have this account with some SES tokens over here. You can get it from our official website, ses.network, and navigating to faucet. So let's get back to developer extrinsics. Here we'll have to select OSS. We'll first authorize our gateway, OSS, and authorize by default is selected here. So since I'm based in India, so I'm gonna select Singapore address. I'll just paste the address here and then sign and submit the transaction. Okay. So once our gateway is whitelisted, you can check it through developers chain state. And again, you'll have to select OSS and authority list. So here you'll have to select your account and you'll see the authorized gateways, like as you can see here, this address matches. And the second step is to purchase some storage space. So for that, we'll have to, again, go to extrinsic, select file bank, and storage handler. We'll have to select storage handler. Storage handler. We'll purchase some mint territory, there's a function called mint territory. To mint, like suppose we want to mint 10 gigs of territory, we'll give it a name. Um, Polkadot. Let's name it hackathon, and the number of days for which you would like to rent this space. So minimum is 30 days, and you can sign and submit the transaction. So again, you can query the chain state for the amount of space you have. Again, select storage handler, and here you'll have to select territory and count. This will give all the available territories like previously I've created. And yeah, you'll see hackathon. So it'll show all the related information like the amount of space used, lock space, remaining space, and so on. So once this is done, now we can actually start uploading and downloading files. So for this, I'll just navigate to our docs, uh, doc.ses.cloud, ses.network. From here, we can go to developers, uh, products, DOS, and API descriptions. Here you can see all the available accounts and the gateways available. You can also see all the APIs we have over here, like uploading and downloading files. Then, but before we start getting uploading and downloading files, there's one more step, which is generating identity signature. This is to authorize, uh, this to let DOS gateway know which user is actually accessing the API. So for that, we can again go to developer, sign and verify, and we can select the account again and just enter a random message. Just enter hello and sign message. So this will give us a signature, which we'll use for our APIs in our API header. So let's start with uploading a file to the SES network. Let me create a file, downloads. Let me create a text vim hello.txt, and I'll enter Polkadot Hackathon. I'll just save it. And I've actually noted down the command here. So you can copy it from here and make changes based on uh, your configuration. So I'll just copy it from here, uh, uploading the file. So I'll just update those fields. I'll replace the signature with the signature we just created. Okay, this is a signature. And the message we entered was hello, and the account address. We can copy it from our account section and copy it from here. Just replace this. Actually, is okay. And the territory which we created was hackathon. Bucket, we can give any bucket name. And the file type which we are uploading is hello.txt with the type of the file, which is text plain. And we'll be using our DOS's gateway address, which is this. So I've already got it entered over here. So let's try to execute this function. So this function will give us a file hash. This is called the FID. This we can use it to track our file. So again, we can go to extrinsic and chain state. We can query like from file bank, and we'll select of The moment you upload a file, it gets processed. So you'll usually find the file in deal map. And once the file is actually distributed to all the storage nodes, you will find the file inside the file function. So this is like kind of a pool where the file is actually, yeah, I'll just execute this. Yeah, so you can see all the segments of the file and the user who has uploaded with the information. Once all those file segments are distributed to storage nodes, you'll see those storage related information in completed lists. So similarly, we can actually download the file from the SES network. For that, we can find the API from our documentation download file. It's actually fairly simple. Oh, one thing I forgot to mention, while uploading files, you can actually use a ciphered header to encrypt your file before you upload to the SES network. And okay, let's now download the file. So again, I'll just download it over here. Give it a name, hello downloaded.txt, and replace it with the file ID. Okay. Okay. So you'll be able to see like, we'll just cat over here, hello download.txt. So you can see we have received the file again. So apart from this REST API, we also have JavaScript SDK. We have in Go and other languages as well. So with JavaScript SDK, what you just have to do is install our node package, which is says.js SDK node.js, and then you are ready to go. All those steps which I showed in my demo will be also able to do it through our SDK. So you can authorize a gateway, then you can create trees, and you can assign how much storage space you need. You can start uploading and downloading files. So I think that's all for our workshop. Hopefully, this will give you guys a good understanding of how you can utilize SES for your project. We are having a lot of bounties and grants. So for the first two best projects who will develop on SES or using SES APIs and tools, we are giving like total $3,000 worth of SES tokens. So I wish all of you all the best, and yeah, utilize SES for your project. Thank you so much.
Thank you, Alex. Perfect timing. Yeah, and we have Max and Philip just made you both as a co-host, so you will be able to share your screens, I'm assuming. So yeah. So next, let's welcome Max and Philip. Both of them are actually senior developers of a unique network that will share with you writing and invoking custom Solidity contracts in the Unix substrate SDK. Easy peasy. Okay, please go ahead, Philip.
Right, thanks you. Does everyone hear me? I suppose the microphone is working. So, well, welcome to this challenge. I'll add the introduction. Matt will continue on with it of course, actually tackle the challenge and what tools we'll be using. But there are some things you need to know regarding the unique network to actually understand why we phrased it the way we did. Why is this the title of the challenge and what the challenge actually is? So first of all, unique network is a parachain on the Polkadot system. We have three chains, the production chain, which is unique, quartz, which is on the production chain. The unique chain is on the Polkadot. There is a quartz chain, which is on the Kusama, and we also have Opal, which is a development network. Now, you will be probably developing on the Opal for the simplest reason that the coins you can use for transactions are valueless, which means there's a faucet which can give you any amount of tokens you need to kind of develop and work. So essentially, Opal is the development. making anything into shifting over to production is really simple. You just change the endpoint and things just work. There is one more aspect of unique networks development. This, how would I say, the bundle of networks. It is the capability that is provided through the Ethereum virtual machine. Among those three chains, we also have an Ethereum virtual machine. We're substrate first, but we do have a fully functioning EVM. And the thing that is very important that I need you to remember from the very start is that in unique network, the EVM addresses used in the EVM one-on-one with substrate addresses, which makes interoperability of the EVM with the substrate basis very, very simple because of this one-on-one mapping. And this actually provides you the ability to use both MetaMask and Polkadot wallets in the same kind of address space. You will need to use a certain function called cost address, which Max will stress very strongly in terms of the use, but that's how the operation. I just have to clarify one more thing before I pass it off to Max, and that is the question. So unique network being an optimized chain for the really features for NFTs. So everything like nesting, dynamic NFTs, composable NFTs, refungible NFTs, all these are covered by the features, which are precompiled contracts, which actually makes it possible to use it without writing any contracts, just by making calls through the SDK to the core functions that are in the palette, contained in the palette themselves. So it enormously simplifies the process of creating and managing very complex NFTs. And the question that arises then is, so what do you need the EVM for? Well, the EVM then is actually the provides a capability of writing contracts to extend the functionality of what you're building. And this might be decentralized minting or some super functionality through, I don't know, complex royalty schemes or whatever you can imagine. But Max is going to show you how actually you connect these to the SDK and the EVM contract, and the Solidity contract that you write within the EVM, how these addresses reflect. And from that point on, your challenges with this and the bounty we'll be providing with is the most interesting kind of interaction between the contracts that is written on the EVM side and the SDK development in JavaScript. From the on, I give it to you, Max. Please show the magic.
Hi, everyone. Can you hear me? Can you see my screen?
Yes, perfect.
Yeah. Screen visible.
Yeah, cool. So, yeah, right. Hey, everyone. So we don't have too much time, so let me jump straight to the demo. For this demo, I will explain how to use unique network EVM precompiles to create native for unique network collections and NFTs. You will understand what are the benefits of using this approach. And yeah, also we provide you a set of tools to rapidly start your development. For the demo, I will show you a very simple Web3 game with slightly silly rules, but this game is very close to one you need to develop through this hackathon. In this game, your contract manages a collection, and in this collection, you can read some creature, which is pseudo-randomly selected from this blue one and this red one. And after that, these creatures may fight against each other. And yeah, if this creature loses the battle, it became slightly exhausted, like this one. Also, your creature can gain some experience, and at some point, if it gained enough experience, it can be evolved. So basically, this creature evolves to this one. And everything I will show is happening completely on chain. So no off-chain services, no backends, and no privilege keys needed to create such experience. Also, here is how this game will look like. So here's your squad. You can breed new creature. You can select some and put it on the arena and fight against the other creature, gain some new experience, and evolve it. As I said, we will provide this boilerplate code. It will help you to concentrate on the application logic, not fighting with boilerplate, setting packages, and connecting to the accounts. So in this boilerplate, you have an access to the Polkadot wallets. Here's the list. Also, we provide an access to the Ethereum wallets through the Wallet Connect. Okay, so here is the first thing you need to know. Take a look to the README. Basically, this is a text version of today's workshop. It's quite comprehensive and explains everything in the details and provides every single link you need. Yeah. So now about this project. It consists of two main parts. The main part at the root is React project. And here is in the contract directory, you may find very simple hardhead project. Let me show you. Here is only one contract here. We have a closer look a bit later. Let me show you a config for this project. A couple of things you need to know. The available versions for the Solidity cannot be higher than this one, 24. We do not support high version for now. Also, you have to use via intermediate representation compilation pipeline. And we also have predefined network here for the Opal, which is testnet. We already deployed contract for this demo, but if you want to deploy your own contract, just provide your private keys and run scripts to run a script to deploy your own contract. Here is the script, and you will find deployment script in the package JSON. So everything is ready to be hacked. So also you will find in the README a link to the faucet bot. Let me find it. Faucet. Here is a Telegram faucet bot. Here you can obtain OPL tokens for free. Yeah. Okay. Now, before we jump to the contract, let me show you how React project looks. Here is app.tsx file, and here is a couple of providers. Wallet Connect provider for the Ethereum wallets. SDK provider is for Substrate wallets and for the SDK. And the account context provider is for the selected account. So very simple. For now, it's main, and that's it. So it's very simple. For the pages, here's only one page, reading page. So let's have a look. Reading page 6. There are a lot of comments here. you will easily understand what's going on here. But let me quickly walk you through this, through the main variables. So first, here's a couple of constants here. This is all these constants related to the already deployed, just hard-coded contract address, collection ID, and this one is for the application logic. Yeah, here is a deployed collection, 3997. Yeah, this is collection. This collection we will work with. Also, a couple of useful hooks. First one is use chain and scan. This hook provides an access to the unique network SDK, and this SDK consists of two parts. First is chain and scan. Chain is for blockchain interaction, sending transactions, retrieving data from the blockchain, and scan is for the retrieving data from the unique network indexer. And also important hook for the selected accounts. We will use it often in the project, but basically it's very simple. It provides an access to the selected address. Okay, everything else is related to the application logic and to the contract. So let's jump to the contract and let's have a look how it looks like. Okay, here's very simple, basically reading contract. Couple of things to notice. So unique network provides a set of precompiles which allows you to mint collections and NFTs, which would be native for unique. So you don't need to deploy ERC-721 contracts in unique network. You can, but it doesn't make a lot of sense. For us, it is better approach to mint native collections and tokens because they will have more features like nesting, like refungibility and so on. But it can be slightly tricky part because it is not always easy to. It's not enough to just mint NFTs. You also have to stick special metadata format to make these NFTs compatible with existing interfaces like wallets or scans. So for simplifying experience, we provide this package, which is unique NFT contracts. Here is the repo for this package. I also recommend to walk through this repo. Let me quickly explain how it works. It provides basically not so much abstract contracts. One contract is for collection minting. It provides create collection function. So that's it. It's very easy to create collection. Just call this function and you're good to go. Token minter abstract contract provides functions to create for creating tokens. Token manager contract provides functions to set token images and token attributes, traits, also retrieve images and trait values. And address validator, it's slightly difficult to explain without examples. So let's return back to the contract and let's have a look how it works. So in the constructor, we create a collection using mint collection from the collection minter contract. We provide some stats, some info for this collection like name, its description, symbol, and this one is for collection cover. Yeah, so that is how it will look like. So this is our collection. It has its symbol, some description, and yeah, that's it. So this code relates to the logic of application. I will not explain it. One thing to notice, main collection is payable function. You need to provide value for collection minting. So do not forget to put 2 OPL tokens for this collection. You can actually implement your own logic. You can pre-fund your contracts, for example, and you can make a gasless experience for your users if you want. But yeah, basically you still need to provide these tokens to the function to mint a collection. Okay. Next very important function is read. This function explains several concepts. First, here is a cross address which we pass to this function. So basically what a cross address is. As Philip mentioned, we are Substrate first blockchain, so we have support for both Ethereum and Substrate interfaces. And Substrate accounts can interact with EVM contracts, but here's the problem. EVM do not understand Substrate format, Substrate accounts format. So to make it possible for Substrate accounts call contracts, we have a concept of account mirroring. So every Substrate account has its own Ethereum mirror. And actually, when Substrate account calls this read function, the message sender for this function would be its mirror. Okay, it works fine, but the problem is if the message sender is Ethereum address, how can we mint this NFT for the Substrate account? Because the owner will be Ethereum address in this situation, right? So for this purpose, we provide cross-address struct. Let me show you how it looks. Yeah, this is cross-address. It is very simple struct which contains 2 properties. If property is for the Ethereum addresses. So if the contract origin is Ethereum address, you need to provide ETH property with its address, and you need to set sub property as 0 for the Substrate. And if the origin of the transaction call is Substrate account, then you set for ETH property address 0, and you put Substrate public key for the sub property. It may sound slightly complicated, but actually it is very easy. I will show you how it works later when we return to the React project. The second important part you may want to use, because you may want to check if this address is really message sender. So you may want to use these modifiers which provides by this address validator contract. This modifiers checks if this cross address is really message sender. In some cases, you probably won't check it, and you may want to allow everyone to mint for every random address. But for this example, we definitely want to owner being the message sender. Okay, this logic is just pseudo-randomly selects creature. So the next important part is this one. We create a set of attributes. Let me show you how it will look like in the scan. So this is our creature. It has 4 traits, and yeah, these traits we provided here: experience, victories, defeats, and generation. And after that, we just call create token, and that's it. We mint a new token. Let me run this. I can call this function from this substrate. This is Polkadot wallet. I will not wait, but let me return it to the project. It will take some time. Yeah, okay. The last thing I need to explain is how token manager contract works. This contract is for attribute mutation. And here is a couple of functions that implements the functions from this token manager contract. For example, this evolve function responsible for evolving NFT when it gains enough experience, which is set to 150 here. Yeah, and if it's enough, it sets different trait for the generation. It increments its generation, and it also changed the token image. So I will not explain the other functions because basically they do not contribute anything to understanding of these contracts. So just have a look. There are a lot of comments here, so you will understand it easily. Okay, now let me jump back to the front-end project. And maybe, yeah, I just created one new creature here. So yeah, this works. Now, let me explain how you can invoke these contracts from using substrate and both substrate and Ethereum addresses. Here is send transaction function. You may find this is a helper function. This function checks if the selected account, which is provided here at the account context, if this selected account is Polkadot wallet, it uses EVM, it uses unique SDK, and it sends transaction this way. Okay, and if the signer is Ethereum wallet, like MetaMask, for example, it uses others as usual. So next we use this send transaction function. Very easy. Here, for example, for the breeding, this handle function for breeding. Here's we invoke this function to create a new token. Okay, one more concept to explain. It's probably how to retrieve data. There are 2 ways you may use. First is using unique SDK. For example, this function for fetching Gladiator. Gladiator is the token that currently on the arena. Let me put some token there. So this function uses SDK, and it's also very simple. You need to provide function, arguments, contract API, and contract address, and that's it. That's how you can invoke data using SDK. Okay, and the second option you may want to use is scan for example, if you want to get a lot of data for example, all the user tokens, it would be much easier, and it would be probably the only way you can do this is using scan. So it's also very easy. I don't think I need to explain how this code works. Just have a look, and that's it.
There's the promise, Max.
So
there's the promise of the easy peasy. We said it would be easy peasy. There you go. It's just these very simple calls and magic happens.
yeah, right. So basically that's it. Just walk through these code examples. The only link you need is unique React template. We will provide this link. So can we drop this link somehow, Philip? So I think
we'll get contacts from the organizers to connect with the developers, and we'll be able to provide that. So don't worry, we'll make sure you have access to this one way or another.
Yeah. Okay. So that's it for me.
And before you close, we have a few more minutes. I don't know if we're going to break the minute, but I just wanted to make some very kind of important notes on this. First of all, let's just recap what we showed here. We used essentially three technologies. We use React to a template to build some kind of an interface. That's not the point of this discussion. React is React. It's just a simple framework through which you enact interaction. However, behind the whole concept of interacting with the blockchain is the idea that you will be using the SDK to do easy stuff. Like, as we said here, invoke the scanner, get the data, read the data. However, the SDK also provides a framework through which you can make calls and implement the contracts that you write on the EVM. So this was the presentation in the sense that those are the elements that are displayed in this example. Now, this example is a game, and we're not saying go out and build games, like copy this and make a different game. This whole presentation is created so that it's actually very, very modular. It was created so you can pick and choose elements that you need to create what you need to do. For example, there is a part that handles the wallet interaction. Just pluck it out and put it in your project. There is a part that makes access, that creates and mints the NFTs. Pluck it out and put it in your project. Your task will be to play around with this concept and implement some kind of a, well, it doesn't have to be a game. It can be a game, of course, which uses an interaction of some contracts, that is distributed computing applied to and decentralized computing applied to some kind of function, and interacting it with the SDK to build something interesting. So make it wow. That's all I can say. Play around with it. And one more point that is very important is the reason why our EVM is not exactly like the Ethereum, the approach of using the EVM is not exactly like programming on Ethereum, is that we keep all our data related to the NFTs on chain, which means they're not contract driven, contract contained data. It's data contained on the blockchain, and you use the contracts only to access the data, which allows you to easily mutate any parameter that you declare as mutable in the NFT. I hope that makes sense. With that, we've kind of completed the workshop, and I hope everybody had fun.
Thank you, Philip, for the recap. Thank you, Max, as well. Okay, just let me quickly share my screen. Yeah, So for here, I just also remind you again for each participating team that after creating your GitHub repo, please remember to submit your complete project information following the competition specifications, and we have some updates for the bounties. So you can basically simply click the bounty details to check through our Dara hacks. You can see we have Vera Network, SES Network, Unique Network, Bifrost, Albania Network, Mubi, and Blockchain for Goose. And if you meet their requirements, please let us know. We will start to collect everybody's preference for the bounties. Okay, so just go back to here. Yeah, if you haven't registered for the hackathon, you can scan the QR code from the most right-hand side. Yeah, you can scan and register. So finally, I hope that all the participants here can gain in-depth scans and growth from this sharing. And thank you for participating today. I wish our participant team to achieve outstanding result in the project. Thank you, Alex. Thank you, Max and Phillips. I'll see you around. Bye-bye.
Thank you, Tracy. Thank you,
Thank you.
everyone. Bye-bye.
Bye.
Thank
Bye.
you.
Bye.
Thank
Bye.
you. Bye.